Today we'll be talking about control flow and decision structures. So with Python you have some built-in keywords if, elif, and else that'll help facilitate control flow. These terms are used in conditional statements. So this whole sentence, or if you want to think of it as a sentence, this line is a conditional statement that says if this executes, or if this expression here is true, then you'll do all the stuff that's indented below it. But before we can do these, we have to be able to make these comparisons. And I have to introduce these comparison operators. So if you go into Python, the comparisons we have are as follows. We have equality. This says if A is equal to B, meaning they're equivalent. Then you have, well, let me clear this. You have A is equal to B, so saying their values are equivalent. Then you have A is not equal to B, and this, everything here evaluates to either true or false, and this is what discrete mathematics will teach you, is something called Boolean logic. It's like one of the introductory things is building truth tables and how things evaluate. This one is true if they're the same and false if they're not the same value. They don't have to be the same referenced object. And this one will return true if they're not of the same value. Then you have A is greater than or equal to B. So this says if the value of A is greater than the value of B, then this is true. Otherwise it's false. And likewise, this one has equality included in it, and you have a similar statement that doesn't have equality. So A has to be strictly greater than B. They can't be of equivalent value here. And you also have the less than or equal to and less than specifically. So if A is less than or equal to B, and if A is just less than B. And B and A and B here are variables, any variables. They can even be specifically values. See here that it in this if statement they've made, they said that the variable x is an integer input. So this is how you get input, is you use the input keyword. And then this is the prompt string. And I'll run something like this in a second. And it'll do these conditionals. So if they're asking you to type an integer, so that's any whole number, and that's one thing I didn't discuss during the integer section, is there's this idea of real numbers or fractional numbers. They're called floating point numbers. And really floating point is a holdover from how it's implemented on computers. The point doesn't float, but how it's represented in a computer floats. It doesn't stay the same. It moves around digitally. And if we talk about how numbers are represented in binary, I'll go over what floating point and fixed point actually mean. So they entered 42 here, and in this control structure, x is greater than 0, so this won't happen. X is not equal to 0 because it says 42. So equal to 1, it'll print more, and that's what you see here, more, because x doesn't fall into any of these conditional statements. And we can create our own conditional statement here real quick. So if we say, and we can demonstrate input as well. So let's call it my number. my number equals an integer cast of the input from the prompt enter an integer. And this will look like exactly how you typed it. So you don't want to, you want to leave a space because this is where the cursor will be. Think of it as like your cursor when you're doing input will be right before this double quote. So if I type it here, this is what it'll look like on the prompt. But if I say this is where the string stops right after the colon, then this is what it'll look like. So you want to leave a space here. And you don't need to put new lines or anything because it'll move to the next line for you. That's how it'll work here anyway. So if you hit standard in, oh, I didn't type input. Right. There we go. So it says enter an integer, and we'll say 20. So now if we say what is x? X is not oh, I didn't call it x. My number, my bad. And you see that it's 20. And now we can do the same stuff here. If your prompt is continuing, this is the first time you'll see this, but conditionals and functions and classes, definitions and stuff are delimited by a colon and then it's tab indented. This is strictly enforced by Python. You can't not do this. You have to do it this way. It interprets lines, like blank lines, and tabs. So it interprets white space, so you have to be mindful of it. So if we say if x, or my num, if my number is greater than 100, and then you have to tab. If you don't hit tab here and you start type, I'll just demonstrate. Print. And you'll see. It says indentation error, expected an indented block. So you have to tab indent this. And if you hit enter twice, like if I tab indent, I can keep doing this. But if hit enter twice, it'll treat that as the end of it. And it didn't do anything because our number is 20, so it's not greater than 100. So again, if my number is greater than 100, print. We'll just say you can just say greater than 100, or my number. Not my number. And this is how you would print multiple things in a single line without doing format strings. You just comma separate it. If you were going to do concatenation, you can do concatenation in the print statement, but you have to cast whatever it is to an integer, or to a string, otherwise it won't work. So if I tried to do is greater than 100, like this, I keep doing semicolon because that's how you delimit other languages. So if you did this, it wouldn't do anything. Here, let's make it so that it would print. And you'll get an error, unsupported operands for type plus integer and string. So this won't happen if you tell it to cast my number to a string, like this. And I forget, I'm not in Python. So you can do this, and this will work. But if you don't want to do the casting stuff, you just have to say like this. They have to be comma separated if they're different values, and this will print just the same. Except there's a oh, does it insert a space by itself? And greater than that. This goes into how strings delimit themselves. So you can see that I'm not putting a space character here, but it has a space character right there. Whereas whenever I did it the first time, I had 2 space characters because there's a space here. If we go back This just gets more into like print formatting stuff, and it's not specifically what I wanted to talk about in this video, but I'll go on a little longer. And maybe make this video like 15 minutes. I'm trying to get this all in here. So if I delimited it with another string like this, well, I keep saying delimited. You can see there's no issue with like the fact that I don't have spaces here. It's because of something called the separator and the end specifier, I believe. So if I let's just do a print statement like this. It can't be tab indented like this, so I don't have to keep writing it. You can do end equals empty string. Now there's no new line character, and separator. Separate equals empty string. Now they're all, well, let's get rid of end here so that you can see it better. Now you can see that there's not, the separator is defaulted to a single space, and the end is denoted as a new line. So if I did this same statement I did before, except I put one space here and I put a new line here, then it'll look just like I said it did, or just how it was before. So this is how it was before, without all these special keyword arguments. And here it is now. So end and sep are, whenever we get to how functions work, you'll get to keyword arguments and default values for parameters, but we're not talking about that right now. This is just for print formatting, some basic, very basic print formatting. So let me clear this, and then we will go back to making this if statement. So if, remember that my number is 20, so if it's greater than this, we'll say print my number is greater than 100. Okay, and then we get into this statement. This is a weird word, don't you think? Elif. Elif is a holdover from C. It is equivalent to else if. This is how it's done in C. It says else if. Which, what it really creates is like this echelon stair-stepping thing, where it's like, if this is true, then do this, else, and then there would be another if inside. You can think of it that way. Else if, else if, else if. These just create deeper nests inside. But it's a little different for how the control flow works. So this says, if this is true, do this. Else, if this is true, do this. So if this condition fails, and this isn't a true statement, x is less than 0, it'll go to the next test, or the next conditional statement. It'll ask, is this true? Well, no. Is this true? Well, no. Okay. And else is just like a catch-all. If all other conditional statements fail, do this thing. There's no conditional. It says only if all these things aren't true will you ever do this. And that's kind of how else if does. So it says if this is true, do this, else, and then so there's no conditional, and then it'll just do this next set of evaluations. So that's how C does it. So the language that Python is built on, C Python, it's kind of a mix, but it's built around the same constructs. So else if my number, and these things don't have to be true or false conditional statements. You can say if my number modulus 2 if this evaluates to a value that isn't 0. So in Boolean logic, you use the values 1 or 0. 0 is equivalent to a false condition, and any number that isn't 0, so not 0, is equivalent to a true statement. It doesn't have to be 1, it doesn't have to be a specific number. Usually 1 is what is used to represent true, but any value that isn't 0 is true. And that's how conditions work. So we can say that if, and essentially all this says is if the value divided by 2 returns no remainder, meaning that it's even, it'll return 0. So that means it's even. So what this will do is this says if the value is not even, because remember, it has to be a value that'll return, or this has to evaluate to something that returns a value other than 0 in order for it to execute. So if the number is even, this won't happen. Print. So what can we say? We can say my number is odd. And then we can say else, and this is what will happen if none of these things occur. Else print. Oh wait, we can also so by missing this, we can also say that the number has to be less than 100. It doesn't say it here, but I'll say it here. These things are also true. So I didn't even write my number right. I'm just gonna quit out of this. I'm gonna close this. Okay. And I'm just gonna re-enter these. My number is greater than this. Print this. And this is why I would rather be doing this in IPython or Jupyter Notebook or something else. So we're almost done with the interpreter. We're very close to just ditching the interpreter and going to the text editor. Let's see. We want my number is odd and less than 100. Else print my number is even and less than 100. So because we already know what 20 would evaluate to, we can say, so it says it's even and less than 100. This is exactly what we would expect because we know that 20 divided by 2 leaves no remainder, so that would mean that it's not odd. Or that it's not, yeah, it's not odd. So it'll say is even. And I really don't want to type this out all over again, so we'll get to functions and stuff later in the video, I believe. Or not this video. Does it talk about functions here? Range, break, pass. Yeah, defining functions. So in the next video, since we have now how to do conditionals, this is how you would do any conditional. There are some ideas that we might get into. I don't know if Python does switch statements. I don't see, but we have like keyword arguments. So once we get to functions and stuff, this will be easier. You don't have to type it out every time. You really don't have to do this. And the way I'm going up and down, you just go up and down. Up and down keys will go through your command history. So you don't have to go up and down and redo all of these. if you make a function that just defines this and you pass an argument to it. And we'll get to that in one of the next videos. So stay tuned.